Hi, welcome to my channel. This is question 4, trigonometry of O level. Now what we are having here, we have a sine 2x equal to 2 tan x 1 plus tan squared x. So we are going to prove, but we are going to use double angle formula, because when you look at this Roman numeral 1, we have a double angle on the left hand side, which is sine 2x. But we can change this double angle to a single angle. So this can be written as 2 sin x cos x. So that is 1. I have obtained this single angle. Now how can I create a denominator? Because what you are seeing here, we have a 2 tan x 1 per tan squared x. We can create a denominator by dividing with the 1. So this is 2 sin x cos x divided by 1. But 1 is equal to cos squared x plus sin squared x. So this can be written as 2 sin x cos x over cos squared x plus sin squared x. So I have divided with the 1. We know this identity from the Pythagoras theorem. Now I can now create a tan by dividing by a cos. I'm going to divide by a cos both in the numerator and the denominator. 1 over cos squared x times 1 over cos squared x. So when I do that, the numerator 1 cos will cancel one of the cos down, so remaining is 2 sine over cos. Then divide by, when we divide by cos squared, here we get 1 plus tan squared x. Now when you look at this is sine over cos, which is a tan, so this is 2 tan x divided by 1 plus tan squared x. Hence the left hand side is equal to the right hand side. Now let us look at Roman numeral 2. Roman numeral 2, we have cos 2x. Now we know that cos 2x is equal to cos squared x minus sine squared x. So we can do as before, we create a denominator by dividing with the 1. So I'll divide by a 1, and that 1 is sine squared x plus cos squared x. Then after, I'm going to divide by cos squared both in the numerator and the denominator. So I have cos squared x minus sine squared x divided by cos squared x. Then down here I'll have the same sine squared x plus cos squared x divided by 1 over cos squared x. So now when we do this, we are going to divide by cos squared x. So here we get to 1, and this one will give us a tan squared. Then down here we shall get tan squared plus 1, or 1 plus tan squared. And this is the right hand side. So left hand side is equal to the right hand side. So this is true. So now let us talk about this number number 3. We are told hence. Whenever they say hence, that means what you have just proved, you have to use it to do the next part. So now we are having tan x is 1 over 7 and tan y is 1 over 3. We need to show that cos 2x is equal to sin 4y. Using what we have above here, we should show that this is equal to this. Now, from cos 2x equal to 1 minus tan squared x, 1 plus tan squared x. We know that tan x is 1 over 7, so this will be 1 minus 1 over 49. This is 1 plus 1 over 49, and it will be 49 minus 1 over 49 plus 1, giving us 48 over 50. And if we divide it by 2, this will give us 24 over 25. Please, this was 49 minus 1 over 49, and this was 49 plus 1 over 49. The 49 cancels. That's why I skipped it. So now, this is the left hand side. Let us talk about the right hand side. The right hand side, we have sin 4y, but this can as well be written as 2 sin 2y cos 2y. We use double angle, but this is 4y, so the half of 4y will be 2y. So if we find sin 2y using this, where I have sin 2x, this will be 2 tan y over 1 plus tan squared y. So tan y is a third, so this is 2 third, and 1 plus a third, that is 1 over 9. A third squared, 1 over 9. So this will be 2 out of 3 divided by 10 over 9, giving us 2 out of 3 times 9 out of 10, and now this gives us 3 over 5. That is the sin 2y. Cos 2y, we shall use this where we shall replace x with a y. So this will be 1 minus tan squared y. Now we shall get 1 over 9 divided by 1 plus 1 over 9. This is going to be 8 over 9 and the other one will be 10 over 9, which is 4 over 5. Now we come and we substitute here that sine 4y is equal to 2 sine 2y is got 3 over 5, and cos 2y we got 4 over 5. And when you look at this is 2 times 3, which is 6, times 4, 24 over 5 times 5, which is 25. Hence left hand side, this cos 2x is equal to sine 4y.